Hi guys, my name is Danica Dvorak and I'm going to be doing a tutorial for problem 13.2.6 out of the Hillier textbook Introduction to Operations Research. This is for my Operations Research class Engineering 340 at Liberty University, and I hope you find it to be educational. So the prompt for this problem says that for each of the following problems, we need to show whether the function is convex, concave, or neither. So a little bit of definition background here. A convex function is a function that is always curving upward or is not curving at all. A concave function is one that's always curving downward or not curving at all. That's kind of a graphical visual definition, so I think it's more helpful, at least for myself, to see the mathematical definition. So let's take a look at that. The mathematical definitions of convex and concave functions are related to the function's second derivative. So a convex function is when the second derivative is always greater than 0. And a concave function is when the second derivative is always less than 0. Now, if you were to have a function where in certain cases the second derivative is greater than 0 and in other cases the second derivative is less than 0, that's when we would have a function that we would consider neither convex nor concave. So this problem has multiple parts. 5 parts to be exact, and for part A, it is asking about the function f of x equaling 10x minus x squared. And there's 2 ways we can go about this. We can look at the graph to see if the function is curving upward or curving downward or neither, or we can look at the second derivative. And in this case, we can't really tell from the graph if the function is curving upward or downward or neither, so the best thing to do is to use that second derivative test. The first derivative here, we can get my pen to work a little faster. The first derivative, if you remember from calculus, you get rid, well, first you multiply whatever exponent is up here by your coefficient, and then you subtract an exponent. So in this case, we would have x to the first. So 1 times 10 is 10. And then we subtract an exponent. So x to the first minus 1 is x to the 0, which would just be 10. And then here we're going to have negative 1 times 2 for this. So 2. And then you subtract one exponent, so we would just have x. So the second derivative, ooh, this is really bad penmanship. That is okay. The second derivative, we end up doing the same thing on the first derivative. So the 10 actually gets canceled out. So we got nothing here for the 10. We cross it out. But we do get negative 2. And negative 2 is less than 0, which by our mathematical definition we used earlier would mean that this function is concave. This function is concave for part. So for the second part of this problem, we are looking at the function f of x equals x to the 4th plus 6x squared plus 12x. And in this case, we can look at the graph or we can use the second derivative test. But looking at the graph here is actually pretty straightforward. It looks like it is curving upward, which by our graphical definition on one of the first slides would mean that this is convex. But we can double check ourselves and see if we are correct. So the first derivative here would end up being, let's see, 4x cubed, of 4x cubed, plus 6 times 2 is 12x, and then 12 times 1 is just 12. So our first derivative would be 4x cubed plus 12x plus 12. And then our second derivative is just doing that same process, but on the first derivative. So here we would get 12x squared plus 12. 12x squared plus 12. And remember we were talking about how it depends on the situation, whether it's going to be greater than 0 or less than 0. But in this case, it is always going to be greater than 0, because if x was -1, or it was a negative number, right? A negative number squared is still a positive number. Or if x was 0, we still have this plus 12, which is greater than 0. So this function is always going to be greater than 0, which means that it is convex, just like this third function is 2x cubed minus 3x squared. And looking at the graph, it looks really funky. It comes up and then comes back down. It doesn't really look like it's doing a general curving upward or curving downward. It's kind of doing neither. So from looking at this graph, my gut would say that it is neither convex nor concave. But let's double check using our first derivative test. So we're going to do the first derivative, which is 6. Oh, my pen is being really funky here. 6x squared minus 6x. And then we do the second derivative, which is that same process on just the first derivative that we created. And this would be 12x minus 6. So in this case, because there's not an x squared, it's just an x, this could be greater than or less than 0, depending on what x we are picking. If our x is greater than 1/2, so if x is greater than 1/2, it is going to be greater than 0. But if x is less than 1/2, then that's when we run into problems and the function is actually less than 0. So this 1/2 is kind of the turning point for whether it's going to be convex or concave. But because it is dependent on this x, it is neither. So just like we thought in the graph before, this function is neither. For part D, the function is f of x equaling x to the 4th plus x squared. And this one, I'm not going to do the second derivative. It is pretty obvious from the graph what this is doing. We can look at this and see that it is always going upward, which would mean that this function is convex. And if you really want to do the second derivative ends up being 12x squared plus 2. And you hear that there's that x squared, which means no matter what x is, it's going to be greater than 0. So this is indeed convex. For this very last part of the problem, the function is x cubed plus x to the 4th. And when we look at this graph, it appears at first glance to be convex, to always be going upward. But then we see, I'll get my laser pointer, we see this little bump right here. And it's kind of like, oh, wait, is that always going up? Or does that qualify it as neither? I'm not sure. So why don't we do the second derivative for this one? We start with our first derivative, as always. So we're going to get 3x squared plus 4x cubed. Same process on the second derivative. We end up getting 2 times 3 is 6x plus 3 times 4 is 12x squared x squared. And we see that there's an x squared here. So your first thought might be, oh, hey, that is convex. That's greater than 0. But there's an x here. And so when x is greater than 0, it is, like the function is greater than 0, and we would think it's convex. When x is less than -1/2, once again, the function is greater than 0, and we would think it's convex. But when x is at this special value between -1/2 and 0, so if you were to pick x equal to -0.25, then the function would actually be less than 0, which means that this function is neither convex nor concave. And we can kind of look at this here and go, so when right here, it's kind of right here, when x is in between -1/2 and 0, that's when we're going to have problems. So we know that this is neither convex nor concave. So I hope that kind of gave you a good view at what convex and concave mean, how to find it graphically, and how to solve for it mathematically. If you have any questions, please leave them in the